Okay, hi everybody. State the inequality of arithmetic and geometric means and prove this inequality. So this is one of these important inequalities. One of those is the triangle inequality, which you can write like this. And another that's super important is this one, arithmetic and geometric means. So now we have to figure out what is it about. Well, it's going to be an inequality, so it's going to be like less than or equal to and something and something. The arithmetic mean is where you add things together and then divide by 2. That's the mean, sort of in the world of addition. Now, in the world of multiplication, when you multiply two numbers together, what should you do? Should you divide by 2? Well, no, you didn't add them, so you should square root it. And so this is sort of like the average viewed multiplicatively, and this is the average additively, which is the usual way we talk about average. Okay, and so the question is which of these goes, which is bigger than the other? And so, as always in math, we experiment before we prove. So we experiment first. Let's try, let's try 3 plus 3 and 3 times 3. Okay, so 3 plus 3 divided by 2, or, well, this gives 3. And this one gives 6 divided by 2, which is 3. So they are equal. Okay, why did I write 6? 6 divided by 2 equals 3. So they are equal. Okay, well, we didn't learn which one is bigger yet. How about 3 plus 4 divided by 2? That's 7 divided by 2. Okay, how about 3 times 4 square root? That's, well, I don't know what this is. Not super helpful. Is this thing bigger than this thing? I don't know. I mean, we could square this, and then we could find out. But that would involve multiplying this by itself, and we'd have to do stuff like that. So why don't I just keep experimenting? And the problem is this square root. So why don't I take 9 times 16? Why? Because I can just get 3 times 4 equals 12. And now I'll do 9 plus 16. That's 25 over 2, which is 12.5. I have made a discovery. The arithmetic and geometric means are this way. Okay, so now let's prove this. So now that we've made our discovery, let's try to prove it. The key to this proof will be getting rid of the square root. How do you get rid of a square root? Well, you square everything. And so in particular, we'll start with, okay, here's the inequality. Now let's square everything. AB less than or equal to a squared plus 2ab plus b squared divided by 4. Now, in particular, you need to be really good at squaring the sum. And also squaring the difference. In particular, if we multiply by 4 on both sides, we'll get this. In other words, these are all if and only ifs. And if we subtract, this inequality is true if and only if 0 is less than or equal to a squared minus 2ab plus b squared. The plus 2 got a minus 4 and became a minus 2. And now we just recognize that this is a minus b squared. But the square of a number is always non-negative. So we have found that this inequality, in other words, I'll just write it out again. Our reader will agree that this is obviously true. The square of a number is greater than or equal to 0. Therefore, we go up the chain, or really, I guess here's the chain, up the chain of if and only if statements, and we've proved our result. Okay? Well, we've done our sketch work or sketch proof. In other words, we just made some calculations. And now to actually write down a proof, you'd want to set up very carefully, like, what are we proving? We will prove that for all a and b real numbers, the square root of a times b, which is sort of a multiplicative average, is less than or equal to the additive average. And then we would say, note the chain of if and only if inequalities, ending with 0 less than or equal to a minus b squared, which is true, and starting with star. And then we point to our chain of inequalities. Here we go. Okay, then that would be a nice proof.